Okay, so today we're going to talk about radians. So a radian is the angle made when the radius is wrapped around the circle. So if you recall from geometry, a radius is the length from the center of the circle to a point on the edge of the circle. So if we took this length and wrapped it around the edge of the circle, the angle within here would be considered 1 radian. And there's a really good video on this Math is Fun website that demonstrates that. So I'm going to go ahead and hit play. So it takes that radius, wraps it around, and shows you that that angle is considered 1 radian. And 1 radian is about 57.2958 degrees. And we're going to see in just a minute here where that number comes from. So let's see why 57.298. So here you'll see the radian. We're going to see how many times it fits in a semicircle. So it's 3.1416 or pi radians. So pi radians is equal to 180 degrees because we can see that this 1 radian, that little section fit there just over 3 or 3.146. Now, if 180 degrees or half a circle is equal to pi radians, how many radians do you think fit in a full circle? So you might have guessed 2 pi, and you are correct. So down below here, it shows you if we were to take that radian from before and see how many times it fits into a full circle, it's a little over 6 times. So it's 6.283 or 2 pi. Also, if you recall from geometry, to find the circumference of a circle, we take 2 pi times r. Well, that 2 pi comes from the number of radians in one full circle. We're going to come back to this page probably tomorrow when we talk about converting from radians to degrees. But right now I want to show you some examples of graphing angles in radians. So I have a few examples here. So the first one is pi over 3. So if we start with our initial side on the x-axis, so remember this would be 0 pi, then if 180 degrees is equal to pi, that means that 90 degrees would be equal to pi over 2, or half a pi. So if I wanted to graph pi over 3, you really want to focus on the fraction here. So 1/3. Well, pi over 3, or 1/3, is going to be less than pi over 2. So I know that it has to fall somewhere within quadrant 1. Also, if I think about taking this semicircle, so from 0 to pi, and splitting it up into thirds, so I'd have about one section here, here's my second section, and then my third. I want 1/3 of that. So my terminal side should go right here. And that would be pi over 3. The second example, 4 pi over 5. So again, focusing on that fraction of pi. So 4/5 is not quite 1 pi, but it is more than pi over 2, or half a pi. So that angle is going to fall in quadrant 2, going to be right about here. And I want you to focus less on being exact with the placement, but make sure that you can really get it in the correct quadrant. My next example, 7 pi over 6. So again, looking at that fraction of pi, so 7 over 6, is slightly greater than 1 pi, because I notice my numerator is larger than my denominator. So again, if I know that this is 0 pi, I have pi over 2, pi, and then this would be 3 pi over 2, or 1.5. Well, 7/6 would fall a little bit past pi. To see how much farther, I might break this up into sections again. So if I want to break it up into 6 sections, so that would be 3 in each quadrant. So let's say we'll break the first quadrant up. So I have 1, 2, 3 sections there. And then break the second quadrant up. So here's my 4th, 5th, 6th sections. And then I want one more past pi. So here would be my initial side. here's my terminal side. So it's 7 pi over 6. Lastly is negative 3 pi over 4. So note the negative sign means that we're now moving clockwise. So my initial side goes in the same spot. So this would be 0 pi. But now clockwise, here I would have negative pi over 2 and then negative pi. So if I want to go 3/4 of the way to pi, if I break this up into quadrants 1, 2, 3, 4, I want 3/4, so it would fall right about there. Focus more on the quadrant that the angle falls within and not the exact placement. The last thing I want to talk about today is finding coterminal angles in radians. So if you recall from Monday and Tuesday, coterminal angles are angles that have the same initial and terminal side. And we found them by adding or subtracting 360 degrees. Well, if I'm working within radians now, I want to figure out, okay, 360 degrees is equivalent to 2 pi. So I can also find coterminal angles by adding or subtracting 2 pi. So for example, why don't we start by taking negative pi over 3. So if I want to find a coterminal angle, I can add 2 pi. But remember, when we're adding fractions, we need a common denominator. So since I currently have 3 in the denominator over here, I'm going to multiply both the numerator and the denominator by 3. So I get negative pi over 3 plus 6 pi over 3. So now I can add those numerators. So negative 1 plus positive 6 gives me positive 5 pi over 3. Let's do one more example. So let's take 9 pi over 2. And this time, why don't we try subtracting 2 pi? So again, I need a common denominator, so I'm going to multiply by 2 over 2. So I end up with 9 pi over 2 minus 2 pi times 2 is 4 pi over 2. So 9 pi minus 4 pi gives me 5 pi, and then my denominator stays the same, over 2.